So the first one is, so this is source and links, and one missing here is the record of this presentation on Figshare, but you can find that it's not there, so I think it's afterwards. So yeah, you'll get that later. So please join the group, right? And we have a discussion document. This is this Google Doc. It's a bit difficult, but it will be in the chat. And you can find it probably on the FAIR Principle for Research Hardware in the discussion there. I'll put it later. And in this discussion document, there's also a link to the presentation itself that I pre-recorded and uploaded on Figshare. Thank you for your attention. I'll stop sharing now and hope to get a nice discussion started. So maybe as a first, does anyone has access to the Google Doc document? Maybe I put the link again. And Matthias, I see you put your video on.
I just wanted you to not feel alone.
Thank you. That's very nice of you. Yeah, so it would be nice if people would follow Matthias' lead. That's of course not mandatory. And
sorry, there's a bit of conversation in this room, but I am listening, and I will pop in later.
Thank you.
So Julian, I mean, this is probably something that would be addressed when the group comes up with a definition of research hardware. So I'm wondering, are you focusing more on the hardware design or the instantiation of the hardware as a physical thing? Because like this open flexure microscope, I mean, that's clearly the design there is very important. But then if we're talking about the Large Hadron Collider, as you said, it's never going to be built again. So the instrument itself is very important there.
Yeah, so that's actually a very good question that comes again in this persistent identifier for instrument, which is dealing with the hardware itself, so the physical instrument. And we're more actually interested in the documentation itself. So closer to what research software is. So it's very about documenting the hardware and sharing this documentation in a way that it's reusable and that one can actually rebuild it in the end, or at least, if not rebuild it because it's too expensive, or that one can control, basically review the hardware itself and get engineers to say, okay, this works, or there's a faulty part here. That's not going to work.
So a very similar principle to open source software, where somebody can inspect the code and say, look, there are some pretty severe bugs here. You can fix them. You've got bad dependencies, and then what have you. So yeah, analogous to that, I suppose.
Yeah, and also the same as for software. The first thing is that things should be there, right? It's not you first need to check, are the dependencies correctly assigned, or before you can look at if the dependency are correctly or are working. And for hardware, there's a lot of elements, and that still needs to be defined. So we recently got to see that also some safety measures are important for hardware, because it could break, and if it's not used correctly, it can be dangerous sometimes. Probably not for the microscope, but if there is a laser, for instance, in the hardware, it's very important that people know that it's dangerous.
Yes, certainly. And you spoke about 3D printers earlier, and they can be very dangerous if they don't have the appropriate safety measures. They can start fires and what have you.
Yeah. I'd like to go around. Maybe I just look at the Google document to see some of you answered the icebreaker session. Thank you. For documentation purpose, it would be nice if everyone could at least put their name there, that we have a documentation of who was there. And maybe I wait 1 minute for people to do that. Where am I? And I see a lot of cooking people at home. Cooking seems to be a nice activity. Yeah, just go ahead and talk.
Yeah, I would have a question, which is, I don't know if it's something you've considered already, and that's the role of other departments. So in RDA, often we're talking about libraries or IT, but what role do you think, for example, procurement departments have to play when thinking about policies for research hardware?
What kind of department are you thinking of?
So procurement, for example, because when buying hardware, everything has to go through the procurement department. And if they had a set of guidelines to check or benchmark, because often the call for tender process is heavily regulated, and there could be an opportunity to influence policy there. So if they have to ask vendors for some statements on the openness of their hardware, or at least that interfaces are available to extract metadata, or I don't know.
Yeah, that's something we haven't considered yet, but that may be a good point. I know that it's working like that for research data management solutions that often is blocked at the university level if you try to get a Dropbox account, for instance, and the university is procuring another tool, basically. But for hardware, the complexity of the hardware might make this difficult, at least on the short term. Matthias, you wanted to say?
Yeah, I was just going to agree with Una. When I think about the situation at my host university, although to be honest, this is more about software than it is about hardware, they hate the idea of open anything, and they just want to pay a provider a certain amount of money, a license fee, and just get the software and all the support, and they don't want to deal with anything else. So I dare say it could be similar to hardware. You try to tell somebody, oh, I want to build a microscope. They'll say, why don't you buy one instead? Why are you building one?
Yeah, And that could be very different from one university to the next. I think that may be very institution dependent and how much resources they put.
Yes, absolutely. I'm if you can tell by the accent, I'm based in Australia, and so we are relatively well resourced here.
Any other question? So maybe you had the idea before this presentation to go to I define some discussion points. Right. Put that in the chat.
I did actually have a question. I'm sorry.
Yes.
It's been back and forth. So I come from a preservation background. And when I'm thinking about research hardware and the question that Matthias asked earlier, when you're thinking about describing the design or describing the instrument, I'm thinking, are we preserving the design or are we preserving the instrument? Have you given any thought to whether this extends preservation to physical preservation if we're talking about research hardware? Like that happens sometimes in museums with time-based media art where they actually have to preserve, the physical object that played whatever the media art was, because it's a part of the installation or the exhibit. If they used an old tube TV, the tube TV is actually part of the art installation, so you have to hold on to it. And it raises all kinds of questions in terms of like, how feasible is it to continue to play something on a tube TV every time you want to display that exhibit well into the future? Are we getting into that territory maybe with research hardware as well?
Yes, we do. And that's what I mentioned with maintainability, right? Because hardware will break, and that's how you repair it should be documented. And also things that are often missing is why decisions were taken to take some component and not others. Because if this component is not available anymore, you need more information that the component itself to choose another one or to choose an alternative. And it's very difficult to foresee what will happen in the future. And you can't really have this preservation for 10 years issue that you have for data, because things breaks basically, and you have to repair them or to replace things, and that's not straightforward how you document this. So that's a very open question and a difficult one.
It's interesting that you bring up the 10-year time period for data preservation, or the idea that most repositories guarantee that they'll hold on to data for at least 10 years, whereas research hardware, like, yeah, what is 3 years and it doesn't work anymore, and then what do you do? I guess there needs to be a plan for that.
Yeah, I mean, it's also an issue for data, right? The hardware that got the data is often at maximum 7 years before it start breaking, unless it's
also
then it's a bit longer. Yeah.
The software drivers or the control software for the hardware often makes perfectly good hardware obsolete because you can't run it in the latest version of Windows. And the IT department will refuse to let you run a Windows 7 computer. So you have to stop using your, $100,000 microscope because the software doesn't work anymore.
yeah, just reading Louis' answer, I will think that more important than physically preserving individual items of hardware is maintaining calibration between related items. Yeah, and that's something we also plan to work with the RDA for that research data management for engineering and some engineering data management communities, because it's very technical, right? So that's a very technical question about hardware, how to maintain it on different time scales.
I would have another question. At the chat, VHS. One problem I've come across a lot, especially in the field of electron microscopy, where we have a project at the moment, is that vendors close everything off. And the option is either to build something yourself from scratch, and then you have the problems of documenting that yourself, which may or may not happen, versus buy a ready-made solution, but then you don't get anything. So to the extent that even the same microscope from the same manufacturer, it's not clear if you're comparing the same metadata at the end between two different laboratories. And I wonder, anecdotally, for the people on this call, how much control they perceive manufacturers to have over this versus their individual institutes.
So if I paraphrase what you said, and you tell me if I'm right, the question is who is responsible to provide you with documentation of the data getting out of the hardware? Is it
Or
you?
at
Is it
least
you?
an interface to get the data out of the hardware. This is what the engineers tell me, that they don't need everything necessarily, but a start would be a standard interface to get the data out. And this isn't always existing. Often they have to use the interface provided by the manufacturer and then code something themselves to get this out.
Yeah. So there I would say it's more the data collected from the hardware and the metadata collected out of the hardware that will need to go through some step of verification, right? And interoperability of data coming from different hardware would be nice. But yeah, and I think that may be a critical point or a critical entry point for closed hardware, where we also want to have a verification process of closed hardware, and probably the first step will be verification of the data output of the hardware. Does that make sense?
Yeah, but there's also, I mean, they feel that it's a David and Goliath battle, because, for example, with microscope, you can't complain against Zeiss. They're manufacturing whatever, and they're a gigantic corporation, and they do their own thing. So from that sense, they feel that it's a losing battle. But I think the question of verification of closed hardware is interesting. Was not clear to me as how you would do this, like a round robin experiment or something like this.
At the risk of getting quite off topic, I found that when it comes to, trying to engage vendors to affect change in their products, you should band together with the other users and say, collectively, we have spent lots of money on your stuff. Now, please make it work the way we want it to work. But that takes time and a lot of work.
Yeah, it seems to me that in the long term for research hardware, there's probably something similar to OpenS for journals required, but that was huge and very time consuming.
Yeah, probably. The thing is, I mean, vendors of hardware are less reliant on vendor lock-ins effect, because they basically sell units often. They don't really want to lock you in their hardware suite, I would say. Or, but maybe I'm wrong there. May depend on what kind of hardware we're talking about. So fifth question is how to define research hardware, and I think that's a very good one. That's the first one. That's the first question we want to tackle with our RDA group, and maybe I open there the floor. So the idea we had was to look for examples or collect examples of research hardware, and then from the example try to figure out a definition. So maybe just ask around to give one example of research hardware and go from there, if it's okay for everyone. Yeah. So we can use the notes to write maybe at the end. And please don't hesitate to take the mic and talk about your examples.
I lost the Zoom window. Oh, yeah, I lost the Zoom window. So I'm interested in open hardware personally. So I do nothing with hardware work-wise, but I love open hardware designs, and I've got a box of fabricated PCBs here. And so I love the idea of citizen science open hardware, where you can build together a sensor of some kind and then get that data contributed to a global data set. Yeah.
And how much do you think it's linked to research, or how do you define in terms of the cloud of research hardware?
So this particular example that I've just put in the document, it's from a German project. It's called Sensor.community now, but it was called Luftdaten, so air quality data. And as far as I'm aware, this data is absolutely used by research projects, and yeah, is an open data set available to researchers to use.
Mm-hmm. And how much was it developed as a do-it-yourself communities or inside research project? How does it started?
I think it was started from a research project.
Mm-hmm.
And they decided they wanted some In fact, I'm not even sure whether they went to the public first or they created a design for hardware for other researchers to build sensors for their own part of the world. But yeah, it is simple enough to buy a kit of the hardware from their website. You could also build it yourself with the designs that they provide, with the instructions they provide. But yeah, certainly created in research for research.
Do you think that hardware sometimes gets conflated with equipment? Is that a fuzzy line there? I was just thinking about, like, you know, even something as simple as medical testing kits. Could that kind of fall into the hardware category?
So you mean reagents, basically, right? And a kit would be mostly.
Or things like
Yeah.
test tubes, sample containers.
Yeah, like, does it have to be
It's-
electronic to be hardware? Is that what we're thinking of?
No, it doesn't. It doesn't. I think, yeah, and most of them are in the end have an electronic component to get the data automatically out of them, because I mean, open hardware is as a nerdy type of users, which love to use computers to get the data directly, but it doesn't have to. It could be as simple as a syringe, right? Or as simple. I never tried to make a syringe. Yeah, Manix?
Yeah, maybe a good example of a non-electronic piece of hardware would be, so I come from large-scale facility background mostly, and in synchrotrons or their lenses and mirrors are important, and you have a huge amount of data on these because they're carefully calibrated beforehand. So they're not electronic. Afterwards, they have motors attached to them, whatever, and you can get data from these. But it's important to have a lot of information on the actual mirror itself before you attach this. So this is maybe a more sophisticated example than a test tube of hardware which isn't electronic.
Yeah,
but I would also say that this is stuff that isn't really problematic, because often this is in-house manufactured, and there's it's more or less open in the sense that all the information is there. Maybe it needs curation, but at least it's available and there's control over it in the institutes.
I think it's a good example, especially since the open flexure microscope is not, so it's just saying which kind of optics to buy. It's not really documenting what the optics are doing themselves. So this part of the design is not really documented to the level of the rest. Thank you. It's a very good example.
Maybe just another example I'm come from a digital humanities background. So the types of hardware that digital humanists tend to use would be things like recording equipment. So your digital camera, for instance, if you're doing an interview with somebody and you're recording it, it it draws the question of like, is that worth documenting? Is there going to be a line where certain research hardware is important to the output to document alongside the outputs, and other research hardware is maybe not so much? Or it just needs very minimal kind of mention of, well, I use this type of camera and that's all you need to know.
I think that's a very open question. So can the data be dependent on what hardware you're using? And how much it does a simple method section is sufficient, or do you need proper hardware documentation? May depend on that question, I think. But I'm not sure.
Yeah, just a question of when is hardware documentation necessary? When is it going to be important? And when is it something that you can, you know, skip that section in your data management planning?
I would say it comes down to whether it's important to know the details of that hardware to understand the results of the research, or whether a change in hardware would change the results of the research, or whether you need the hardware to reproduce or replicate that research. So with something like an audio recorder, if you're doing, say, oral history, you're recording words somebody is saying, perhaps the exact type of audio recorder isn't quite as important as if you're doing research into vocalizations of whales or something, which are of, you know, very specific frequencies. So you need to calibrate your equipment, or you need to have equipment that records at that frequency.
Yeah. And also I imagine you could change the behavior of the people if it's a mic they don't see, or if it's a whole room they are in, right? But yeah, I wonder if it's something you built yourself, you probably want to document it. And if it's just something you buy, a simple description may be sufficient, probably. With the idea that so when you buy something, you often get description of things, and this is not specific to hardware, that those description can't just disappear with time. So it's important to preserve them in your project itself. But it's probably a bit outside the scope of the hardware description itself. Great examples, keep it coming. So just read Louis' comment again. I think conversations like this are so helpful because they highlight the complexities and variabilities of research hardware. To my mind, this points to the considerable utility of open science hardware as a subset of research hardware that enables us to really scrutinize all aspects of hardware creation and integration into research ecosystems. And I can just back up these comments. And thank you all. Had a question about So optics example, you said calibration was very important, more than how you built it. Is that what you said?
I just did some emergency looking for relevant papers with some examples. And I added 2 links in next to the example in the minutes. I'm not sure they're the best papers. They were the fastest ones I could find. And I think one is how the equipment is manufactured. Some of this is following standard procedures, some of it is experimental. And then the other is calibration. So typically what happens is that one institute specializes in manufacturing mirrors, and the others will either have their in-house capability or they'll try and commission this. There's not any industrial manufacturers, or very few for these. And this will be built, shipped, but they're very delicate. Often they have like less than 1 micron precision over 1 or 2 meters, which is very fine. So then when it arrives after shipping, then there's calibration taking place again, very fine. And finally, it's installed in its position in the beamline and checked in commissioning. Yes. And all the motors are attached and so on and so forth. And that increases the degree of complexity. But I think that's coming into layering different things. So yeah, I put 2 papers there, which are examples, maybe not so easily digestible because they're written for other researchers looking at mirrors and gratings. Maybe they're helpful.
It reminds me of an instrument that is at the university I'm based at. Sorry, and I'm looking back to, here we go, Louisa's comment, more important to physically preserving or maintaining calibration between related items. So it's an instrument used to work out how old a rock is, how old a mineral sample is. But this instrument is really big and very complex, and no 2 of them are the same. So you can buy one, well, you can buy 2 of them, and they can be installed at the same time, but they'll behave differently. But the most important thing is when you're using it to analyze a sample, the first thing you do is actually calibrate it against a standard. So there are organizations who manufacture these standard fake minerals. And so you analyze that, and then you analyze your real sample, and you compare the analyses to then work out how old your mineral sample is. And when you share the results of that research, you always have to say, I used this standard calibration material to then work out how old my mineral sample is. And in fact, then that leads to, harks back to what Beth asked, what is hardware, what is equipment? Are those standards, the standard calibration materials, are they also considered?
Often it's impossible to, without that standard calibration measurement, it's impossible to tell if any subsequent data coming out of the hardware can be used even. But I think it depends on the type of calibration, because there's the calibration you do during commissioning, and then there's the calibration you do every time you make a measurement, which is probably coarser. And in the end, you need both, but it's probably not the same person doing both even.
Yeah, it sounds to me like you have a calibration of the machine first, and then what you will compare as a standard is more like what's called positive control of your experiment. You have in your experiment a positive control that says you what you would expect to see and what you are comparing to. Basically, like you have, if you do, or at the badge is if you look at the Western blot for the size of what you see, you basically have one line which is a control, which you know what's inside and what the lines should be, that would be the size, because distance will be different from one experiment to the next. So you need calibration inside the experiment. Right?
I think some of what we've been discussing here is leading us towards one of your discussion points that you've got here, Julian, about personas. Who's going to use these principles? Who are we writing them for? In trying to figure out what should be documented and what counts as research hardware, I guess it depends. What do the users need to know? And if we think about it from that perspective, I think we'll get closer to our answer as to what needs to be documented.
Yeah, great comment. Should we move to the next topic and look at personas? Maybe we'll go around in circles.
I think personas is good. I have two answers straight away. The first are engineers. The engineers commissioning instruments are responsible for installing them. And they're caring about making sure everything's working properly. So they care a lot about this. And they're also more open-minded than scientists in general, I would say, when considering open data. And then the second is the scientists who want to analyze the results. But I think this happens on two different levels. The engineers, if we're thinking from a hardware perspective, are often concerned with very low-level interfaces. And scientists, when they're worried about hardware, this is generally more commercial stuff, where they're blocked by proprietary software analysis tools. And there, I would come back to a comment from earlier, that manufacturers depend less than publishers on this trapped model. I think for some things that's the case and others not. So I've been doing a lot of work with electron microscopes recently, and they've told me that there's often this subscription model now where you need to keep paying for licenses to be able to analyze your data or extract it afterwards, that they want to hook you into the entire software suite to get access to the hardware, more or less, in the long term. So I'm not sure I would write that off entirely.
That's
This
a bit
comes
like-
back to your oh, sorry, Matt. I'm thinking about the question about data extraction, about getting things out of hardware systems. If you are dealing with proprietary software that's reliant, that's tied into particular hardware, and it's all stored within the system, and there isn't a exit point. The vendors don't allow you to get, or don't allow you to get it out in a way that's then useful because it relies on the tool. Yeah, that's a whole other question.
Is it, that's a question, huh? Is it an all other question, or is it a critical point of the whole question? And that maybe depend on whether you're an engineer or a researcher, or somebody in the university administration, which is responsible for long-term equipment. Or how you call those person in the personas? You You mentioned them before, right?
Procurement.
Procurements.
Or I think also in personas, you mentioned the safety before as well. So safety groups maybe also have a role here.
Yeah, like also so there's sometimes the people installing the hardware are making sure everything works are researchers. So I've seen that a lot with imaging facilities, where basically buy the 2-photon or photon microscope, and then a researcher become responsible to make sure that it's calibrated correctly every now and then, and making sure everybody has access to it. And so I think there's probably some blurry difference there, or mostly you need the researcher to know what the critical points in the calibration is for the engineer to know what he has to deal with in priority.
Another persona is lab technicians. So not necessarily the same degree of training as an engineer, but certainly important for keeping the lab running.
So I'd like to ask people which haven't spoken yet to just tell us what their interests and are, if they feel they're on personas in this ecosystem. So please, anyone who hasn't spoken yet, take the opportunity. You may also write if you don't feel like talking.
There may be some awkward timing with this session happening in the middle of the night for some people who are maybe just hoping to listen in.
I'm enjoying the novelty of an international conference that is in the same time zone as me. It's wonderful. For once,
Yeah.
I don't need to be up in the middle of the night.
Yeah, that's also what I told my other people in Berlin next. For once, we have to get up in the middle of the night. We should not complain. Just be happy that it's the exception and it's not the rule.
I can add another persona. I'm thinking about preservationists, the archivists who are going to be dealing with this stuff later on.
Can you give more details, because I'm not really, I don't really know who those people are. What are they?
Oh, so yeah, okay, this goes back to my question of what are we preserving? So you think about the data that's extracted from research hardware systems. Some of that data is going to go into a long-term preservation repository. And so it will be held onto for ages. And there are a lot of policies that have been developed to guide how archivists kind of continue to make that data accessible, because there are changes that will inevitably have to be made to file formats so that you can read something 300 years from now that, you know, was originally created as a PDF and now needs to be like a 3-dimensional hologram or something. But hardware, okay, so how long are we keeping the hardware for? Or how are we keeping the information about the hardware? What is it that we need to know in case someone in the far distant future wants to recreate this piece of equipment? Or wants to understand how this equipment worked?
I think this is a really interesting question. And I wonder if science historians could tell us something here, because it's common in physics to repeat historical experiments, especially in undergraduate degree, with something approximating what was originally used. So it's not the same hardware, but there's, I wonder what the distinction between the hardware and the experiment is, but often it's very, very close. Yeah, so maybe historians of science could give some insight there, using past precedent on what level of information is relevant.
Yeah, that's reminiscent of all the work to try to get to understand how they build the pyramids, which could be seen as an hardware, right? And all the know-how how to do that has been lost.
Roman concrete. We don't know how they built their concrete.
Yeah, and I was yesterday in the north of Germany, where they rebuilt a very old boat, only in wood, and they found wreckage somewhere and tried to reverse design it and rebuild it. So it's very impressive. But yeah, that's nice questions, and for research hardware too, probably. A bit less fun than a wood boat.
So another thing, so talking about FAIR principles for research hardware, the other stream you could consider is how FAIR research hardware can enable FAIR research data. So how do you need to design your research hardware so that the data coming out of it is more fair than it would be otherwise?
I've been asked this question recently from people building new particle accelerators, which are in commissioning. And they want to try and design these, to ensure this, basically. And there they have control of everything. So this is achievable. But it's a lot of conceptual work at the beginning and a bit of a cultural change in how they're working as well.
Yeah, it's also like often in FAIR data, it's pretty easy to implement it at the beginning of the process. But if you try to do it at the end, it's a nightmare, because basically everything has to be rebuilt in terms of software. And we have that in terms of behavior setups, in my case, where the data coming out of it, you can get it basically either in text or in a proprietary format, or in a format that nobody can understand unless you get the documentation out of it. And so this, to build it in a way that the data is more fair, it's often a software issue, actually, most than an hardware issue. But as we said, software is part of the hardware. So it's very, very interesting point, and also talks to me a lot, I would say. So good morning, Olibelli. I just send you again the link to the notes where we're working. And there you can also get a link to the RDA group and just join the group and you'll be in the mailing list. And thank you for joining. And so and we were trying to list personas at the moment with some going back to examples and questions. So far we have engineers installing hardware, researchers analyzing the results, procurement teams, so people which are in charge of buying stuff for the university, safety groups that probably needs to know what dangers are linked to any hardware, the lab technicians, and the archivist, preservationist, which are on one side needs to know what data to save, and then the data coming out of the hardware, and secondly, what information about the hardware itself needs to be preserved, and what know-how needs to be preserved to be able to rebuild it. So
I've got one or two more personas. Data engineers, so the people who build data processing pipelines, distinct from the engineers who commission instruments, because I dare say that the engineers who commission instruments are more your traditional kind of engineer.
So that's probably mostly software engineers then. Or?
Yes, yes, and also research software engineers.
So what's the difference?
Research software engineers will write original code, original software, whereas data engineers are more concerned around the data itself and getting the data moving from one place to another and transformed. So they might not be writing code, but they might be creating workflows that link existing code, and so that they're building the pipeline that gets the data from the sensor network into the data center.
Okay.
Or an example from my part of the world, the people who are building the data pipeline from the outback to get the petabytes of data into a data center in Perth from the square kilometer array.
So and if we compare this role to a data manager, what would be the difference there? You don't work with the researchers that much, or?
Well, a data manager then is something else. So they manage the data. They care about policy. They care about procedures, intellectual property, what have you. They care about making sure the data is managed appropriately, looked after, and is available for use, or is protected properly. Thanks, Siobhan.
Mm-hmm. Okay, so I think that's very interesting that it's actually engineers building hardware is not yet in the list. I still add it, but
maybe it was too obvious.
Or maybe none of us is doing that.
I think
don't
Siobhan makes a good, oh, sorry, Mannix.
No, sorry, please.
I was going to say Siobhan's point about administrators, policy writers, I think they're probably a persona as well that will use this. It's fair to say that they're going to maybe not look at individual research hardware descriptions, but certainly at the process of documenting research hardware in terms of the policies that they then write around who should be documenting research hardware and to what extent.
That then leads me on to think about university commercialization officers. So the people who hate the idea of open anything because they want to patent everything and commercialize everything. But it is possible for open to coexist with commercial. Free the IP, but sell the services.
Yes, very good point.
I feel like that should be a slogan on a mug somewhere. Free the IP and sell the services.
I mean, look, something can be as open as you want it to be, but there'll still be somebody in the world who'll just want you to do it for them. Or need a bit of a hand getting up and running or something like that. It's a relatively successful business model these days.
Yeah, I think there's an issue there. So what the expense we have, there's a couple of companies that are actually doing just that, taking open source hardware and trying to build them. And the issue is that you cannot have a large margin because otherwise people will cry and say it's, it's not working. But the second and most problematic stuff is that often the documentation is not enough, or the open hardware is not ready to be commercialized. It's just in the prototype phase, and it's very difficult to choose what hardware you'll focus on getting it to a more commercialization ready phase, and how you build that.
I'm just looking at the time and we've got about 3 minutes left in this session. We've managed to fill up an hour and a half with this conversation, and there's a lot in the notes document. So thank you, Julian, for leading a really exciting session.
Thank you for making this happen. So for those still interested, there will be a second session on Thursday, much more earlier. So that will be in the middle of the night for me, that time for real. And hope to get even more input then. But I think we got very far today. That's first very interesting to get some other inputs. And yeah, just want to invite everyone to join the group. And yeah, I think it was very lively. The start of my day is really good. Yeah, and yeah, I put the link to the note again. Please add your name at the beginning of the document so that we know who was there. And can always come back to this document. I think it will be open for quite some time. And yeah, thank you all.
Thanks very much.
We'll see you around.
Thank you.
Thank you.